In today's video, I'm going to show you how to use the integral test for convergence. In this video, I'm just gonna directly do some problems so that you will see how we can tell the convergence or divergence of a series using an integral test. Let's get started. Number one. So the question is this: the series n e the power of minus x squared as n runs from 1 to infinity. Okay, this is our series. Now we are trying to see if this converges, all right, if this converges or diverges using the integral test. So when we use the integral test, we need to start by considering three important things. First of all, we have to check if this series is continuous. Okay, continuous. Okay, continuous. All right, and then the second one is if this is positive. All right, if this is positive, if the series is positive, and then the third one is if this is a decreasing. Okay, a decreasing series. Okay, decreasing, a decreasing series. All right. So if these three criteria is met, we can just go ahead and then check using the integral test. Now, I'm not gonna go in detail about these three things because you can simply see that this one is continuous, positive, and decreasing. And then if you forget how to tell about this, I refer to read these some points about calculus 1. All right. But we know that this is continuous, this is positive, and then this is decreasing, and then directly going to show you the integral test. All right. So after you confirm these three, the first thing that you have to do is you have to change. The first step is step one. Okay, step one is you have to change this series into a function form. Into a function form means now f of x, okay, f of x is equal to, whenever you see n, you have to change that x. Okay, so x e the power of minus x squared. All right, this is your um, function. Okay, f of x is x e the power of minus x. What I did is simply I convert that n into x, and then this is f of x. This is the first step, right? Now the second one is maybe just next to it. I can do this. F of x, okay, f of x is equal to the integral of x e the power of minus x squared, right? dx, the integral of that function from 1 to infinity. All right, this, you can consider this as just first step. All right, now the next one is you have to write this one into limit expression form, that is this, the limit. Remember, after all, we are doing the integral test, so the limit as t approaches to infinity of 1 to t of x e the power of minus x squared dx. Okay, times dx. Now this is time to use the u substitution and then to remember how to integrate the integrand. All right, so I'm gonna use the u substitution here. We're gonna use the u substitution here. So let's u. Okay, how to choose u, how to integrate using u substitution is in another video, and then you can check the other videos about how to integrate and then how to choose u. So my u is gonna be minus x squared. All right, this is my u. All right, this is my u. If this is my u, the derivative of u is gonna be minus 2x dx. Okay, minus 2x dx. Now from this I can calculate dx by dividing both sides, minus 2x minus 2x. I'm gonna get du over negative, if of course, over 2x. All right, so remember, these things are very important. Those things are very important. I'm gonna go ahead and then substitute all these ingredients into my integral. Okay, into my integral. So that means that the the limit, okay, as t approaches to infinity, all right, from 1 to t. okay, of x e the power of, now remember, instead of minus x squared, I'm gonna substitute this minus, I mean u, because that's my u now. I just substituted by u over u, the power of u. And again, instead of dx, I'm gonna substitute this dx, which is negative du over 2x, okay, over 2x, all right? Now this is time to observe. This is time to observe. When you observe this, what you see is there is x at this point, and then there is x on the numerator. I just can cancel that one, all right? And then I can rewrite this one in different form, or the next step is gonna be this. Look at that. There is negative here, there is negative here, and then over 2. So 1 over 2 can go outside the limit. Okay, I can bring it to the front. 1, negative 1 over 2 times the limit of what? The integral. Okay, the integral of e the power of u from 1 to t as t approaches to infinity. Okay, as t approaches to infinity. All right. And then I hope you know that what is the integration of EU. The integration of e to the x is just e to the x, right? Now this is going to be like this, all right? 1 over negative 1 over 2, negative 1 over 2 times the limit of, look now, e the power of u is going to be e the power of u uh, when I take it out from the integral. Sorry, just look at this. This is going to be e the power of u, all right? E the power of u, all right? E the power of u from 1 to t. Well, t runs to infinity, okay? So this is it. But remember now, but don't forget that u is, remember, this is minus x squared. That's just equivalent with t minus t squared, okay? I'm gonna substitute it now, okay? So this is gonna be negative 1 over 2, all right, times the limit of e the power of minus t squared, right? As t approaches to infinity, minus, right, e the power of negative 1 square, all right? Negative 1 square. Great. Now, so far so good. The next is now this. This is equal to negative 1 over 2. Let's substitute our limit now, okay? So if I plug in infinity in t, that's going to be what? That's going to be e the power of minus infinity square, which is e the power of minus infinity. Actually, this means that it is 1 over e the power of infinity, which is just almost 0, because 1 over huge number. So the first part is going to be just 0, all right? The first part is 0 when I plug in t to infinity. And then the second one, e the power of negative 1. And you know that e the power of negative 1 is simply 1 over e, okay? 1 over e. So this is going to be minus 1 over e, okay? 1 over e. So look at that now. So negative 1 over 2 times 0 is 0, 0. Minus minus is going to be plus. 1 over 2 times 1 over e is 1 over 2e, which is the same as 1 over 2e. Okay, look at that now. This is a number, because you remember e is a number, right? E is equal to a number, 2.78. You can go that. So this is a number. Simply when you divide this and then use the calculator, you will get just a number. So that means that my series converges, okay? My series converges. Therefore, I can say therefore the series, okay? The series which is the as follows, n e the power of minus x squared as n goes from 1 to infinity converges, okay? It converges, okay? It converges because I have this limit, which helps me to decide my series converges, okay? Okay, so this is how to do or how to tell the convergence using the integral test. Let's do one more question, and then that will be hope so easy. All right. So number 2, okay, number 2, because you can have different kinds of questions in different times. So again, use the integral test, okay? Specifically the integral test. Use the integral test to tell for this series, okay, the summation of 2 over 5n minus 1 as n runs from 1 to infinity, okay? This is the same thing. Now, using the same fashion, okay, the same fashion, first we consider this is continuous, positive, and decreasing, okay? The three criteria, okay? It's continuous, decreasing, and a positive, okay? Now, I have to change this one into f of x, okay? So this will be f of x is equal to 2. When I change to f of x, all I have to do is just convert the n into x, simply 5x minus 1, right? This is it. This is my function. The second one is now, the next one is, let's go ahead and then put it in the integral. So this is simply mean that the integral from 1 to infinity, okay, of 2 over 5x minus 1 dx, okay, dx. Again, I can change this one further into limit expression, okay, limit expression. The limit of 2 over 5x minus 1 dx from 1 to t as t approaches to infinity, okay, as t approaches to infinity. Okay, again, now this is time to integrate my integrand, okay? So to integrate this, as usual, let's use u substitution, okay? U is equal to the bottom one, 5x minus 1, all right? So, and then du is gonna be what? 5 dx. Since I need dx later, let me calculate dx. Dx is equal to both sides over 5 du over 5. Okay, these are very important ingredients for my calculation. All right. Now let's go now. Let's go. So what I'm gonna do is this. Let me substitute everything. Okay. So that's gonna be the limit. The limit as t approaches to infinity from 1 to t. Okay. I have 2 here over the bottom now. The 5x minus 1 is already u. So I'm gonna substitute that by u because I let that u. All right. Times the dx is now du over 5. This is gonna be du over 5. All I did is just simply substitution. I'm substituting, all right? Now, look at this. When you observe this one, I have 2 in the numerator and then I have 5 in the denominator, 2 and 5, okay? So I'm gonna take them out of the limit. So that means 2 over 5, okay? I can bring them to the front. The limit, okay, I have to deal about this one now. T approaches to infinity of the integral of du over u, all right? Du over u, right? So this is simply mean that I can further rewrite this one like this, okay? 2 over 5, right, times the limit as t approaches to infinity of the integral of 1 over u times du, all right? Now, you remember this one, I hope, 1 over u, the integral of 1 over x is ln x, okay? That's ln x. So this will give me this, right? 2 over 5 times what? The limit of, okay, as t approaches to infinity of ln u plus some constant, okay, ln u that runs from, don't forget this, from 1 to t, obviously, from 1 to t, and then from 1 to t, from 1 to t, okay, from 1 to t, right? But you know your u, I can change my u, okay? So 2 over 5 again is times the limit, okay, as t approaches to infinity of ln, what is u now? Remember u, your u is 5x minus 1 at the beginning, okay? Of 5x minus 1 minus 5 ln of 5 um, 5t, just 5 times 1 because that's the one I have, times 5 times 1 minus 1, all right, because that's the one. I'm plugging this one, and then this x can be t, okay, this x can be t because that's the t now. So like this, okay? So this is gonna be 2 over 5. Look now, I can start plugging now. If I plug in t this infinity, okay, ln of 5 times infinity just infinity. So this whole term right here is just huge number, okay, which is infinity, huge number. This is just infinity minus, well, this is insignificant. Ln of 5t means 5 times 1, 5 times 1 minus 1 is ln of 4, okay, ln of 4. So if you look at this, this is in general will give me, this will give me infinity, okay, infinity, because this infinity minus this number is insignificant number, so that's infinity. Hence I can conclude that, hence I can conclude that this series diverges, okay, this series diverges, okay, this series diverges. Okay, so to summarize this a little bit, the first thing you have to do is you have to remember to convert into a function form. After that, you have to just plug in this function in this integral, and then just write in limit expression form. And then when you integrate this one, you have to remember the u substitution, or if you have to use another method, just you have to use another method. And then after that, just keep continue substituting, and then be careful calculating your numbers. Finally, you will get a limit of specific number or an infinity. If it is a specific number, you say this converges. And then if you don't see that, but instead if you get an infinity, you say this diverges. Okay. All right. I hope you enjoyed this video that shows how to uh, check the convergence using an integral test. I will see you another time with another video. Have a great time.